Okay, finally on problem 12. Wow, number 11 took a really long time. That's okay though, because math is fun. So we have now a similar idea to problem number 11, except now we've opened it up and said that we're looking for all solutions. And so we're going to need to express our answers as multiples, integer multiples of some solution on 0 to 2 pi. So let's go ahead and find the solutions on 0 to 2 pi, and I'm going to start by making a substitution. I'm going to say let x equal cosecant of theta, because then I can rewrite this as x squared minus 3x plus 2 equals 0, and it's just a quadratic that I need to solve. So how does this factor? Well, it's going to factor as x and an x right there. We have to add to 2, so we're going to need a 2 and a 1. I'm sorry, we need to multiply to 2, so we need a 2 and a 1. And notice that the 3x is negative, so both of these need to be negative. So we get two solutions, x equals 1 and x equals 2, but those are solutions in terms of x, and we need solutions in terms of theta. But if x equals cosecant of theta, then it's like we're saying 1 equals cosecant of theta, and also 2 equals cosecant of theta. But again, let's not think of this in terms of the reciprocal functions. Let's make them either sine, cosine, or tangent. So sine is a reciprocal of cosecant. So the reciprocal of 1 is 1 equals the reciprocal of cosecant is sine of theta. And same here, the reciprocal of 2 is 1/2 equals the reciprocal of cosecant is sine of theta. And so we need to think about the unit circle. Where do we get values of 1 or 1/2? Well, 1 happens when we're straight up at pi over 2. When does 1/2 happen? Positive 1/2? Well, that happens right here at pi over 6, and also right here at 5 pi over 6. So we have our three solutions in terms of theta right there, but the problem is those solutions are only on the domain 0 to 2 pi, and this question wants solutions on the interval negative infinity to infinity. And so we need to express our answer as a multiple of these solutions. So the idea here is that if I were to go one full revolution around from my first solution, I would get back to it, and that would be another solution. And I could go in the opposite direction too. It doesn't matter. But it does have to be a full revolution, aka 2 pi. And so I need to express my solutions as, I'm going to use the first one, pi over 6. So theta equals pi over 6 plus a multiple of 2 pi. So I'm going to say n times 2 pi such that such that n is an element of the set of integers, negative whole numbers, positive whole numbers, and 0. Because again, any multiple of a revolution is just going to get you back to the same spot. So that's one solution, or one set of infinite solutions. The next set will happen at multiples of pi over 2. And so we'll say pi over 2 plus n 2 pi. You could say 2 pi n. That sounds better, I think, but either way is acceptable, such that, again, n is in the set of integers. And finally, the last one, theta equals my last theta value, 5 pi over 6 plus n 2 pi, such that n is an element of z. So it's really not any more difficult to express all solutions to the problem. We just need to be precise in how we set it up.